This is Antoine and welcome back to our newest episode of Mastering Manufacturing. Today I want to be showing you the ins and outs of a whole anodizing process from A to Z. By the end of this video you will know exactly how the anodizing process works, so let's get started. So in order to show you better how the anodizing process works, we chose to bring in some of the sample parts to the anodizing facility. One part or one set of parts will be without machining marks and another set will be just purely anodized with its still machining marks underneath the anodizing layer. We're showing you an operator who's doing a pre-surface treatment, which we call bead blasting. Basically, we blast a very fine media onto the parts in order to remove all the machining marks. Bead blasting is the most widespread method that is used today to remove machining marks before the anodizing. You can see bead blasting being done on many consumer products. As opposed to what many people think, bead blasted is not quite automated. It's not quite an automatic process, and you can see the operator in the videos just holding the part by hand, meaning it's probably better to have the anodizer do this step rather than a manufacturer generally, because they will know better what cosmetic look they want outside, meaning at the end of the anodizing process. So now that we have our two parts ready, we need to get these two parts ready for the anodizing process. And that is actually the first step in itself of the anodizing process, which is the racking. In this step, we're basically taking the parts and putting them on what we call a rack, which will help conduct electricity as well as holding the parts during the whole process. And that is actually quite a crucial step, because if the parts are not well racked, they may fall, the anodizing layer may be inconsistent, etc. So really, first step is carefully hanging the parts onto the anodizing racks. The next step after that, that's the actual first chemical step per se of the process, is what we call the chemical cleaning or chemical etching. What we're basically doing as a step is taking a very strong solution of sodium hydroxide and we're dipping the parts in it. And the reason for this step is twofold. Is that the first reason is that if the parts are not cleaned, basically we've touched them with our hands, they may still have some machining oil left on them, and if we don't get that grease out, this will prevent the anodizing layer from building up correctly on the part. The second reason that is a bit more functional is just because the anodizing layer actually adds a thickness, but it adds a thickness in a non-consistent way on the part. Meaning if you have your part here, the anodizing layer will go 2/3 in, 1/3 out. If this is your original surface, this is what your end part will look like. So basically by etching the part, you will basically with etching remove a little bit of a thickness on the part, so that after the anodizing process, basically your part has the exact same dimensions that it used to have before. So after a rinse, the parts then go to the next step of the process, which is called desmutting. Basically, after the etching, the parts are left with something on the surface that's called smut, and that's the very dark things that you see on the part that's most on the left on your screen. Basically, all that is not aluminum in the alloy, so the zinc, the silicium, and etc. have reacted probably badly, and all the inclusions, they have not reacted very well with the sodium hydroxide solution. So basically what we're doing with the desmutting is that we're removing all of those elements with an acid solution, so that these do not impact the anodizing process, because anodizing of course only works with aluminum, and if you have too many elements like zinc or silicium left on the surface of your part, you're going to see small spots that are actually going to impact both the functionality and the cosmetics of your part. And then we're doing another rinse. After the desmutting is done, we then move on to the main step of the anodizing process, which is the anodizing step. So here we take the parts that are still on the racks and put them in a bath with a sulfuric acid solution where current will pass through, and the aluminum alloy will be converted into the anodizing layer. And so because every part is unique, building up an anodizing layer is not like baking a cake, for instance. You need to be very precise depending on the properties of each part, mainly the surface area and the conductivity of the alloy. So basically what you can see the operator here is taking out the parts of the bath after a certain amount of time and then checking exactly the progress of the anodizing layer. Much like you check how much a cake is cooked after 20 minutes to make sure you don't go over, basically. Once the thickness of the anodizing layer is as per spec, let's say if it gets to 10 or 15 microns, then the operator will take out the parts from the bath and will move then to the next step, which is the rinsing step. So that rinsing step is actually very important, because if that rinsing step is not done correctly, basically as you have a little bit of a viscous film that is still present on the parts. If you don't remove that viscous film, especially in the little holes or the little features of your part, that viscous chemical film may stay and then damage the anodizing layer after it's set, and especially the colors, leading to what some might call bleeding or leaching. After that rinsing is done, they can then move on to the colors. At this stage, the anodizing layer is pretty much ready, and if you were to look at it with a microscope, you would find pretty much honeycomb-looking pores, basically. And those pores are still pretty much open at this stage, and because they are open, there is some space inside to put a dye. And that's what we're gonna do in this step, basically. And basically the dyes, you can see here that the parts are being dipped in the dyes that have been diluted into water. Those colorants will just seep into the pores and give the color to the parts. Now the last part, which is sometimes an overlooked one, but it's really important to make sure that these parts are properly finished, is the sealing process. And what we mean by sealing, if you remember before, we mentioned pores, right? Pores have been created on this material and you need to close these pores, and that's basically what we're doing with the sealing step. There are two main methods of sealing an anodized part. One is hot water sealing, where you put the parts in boiling water basically for a couple minutes, or the other one is cold water sealing, which we chose here, which is done in a nickel acetate solution. Both pretty much serve the same end function of making sure that one, the anodizing layer gains the full potential for its chemical resistance, and two, that the colors that we worked hard in putting inside the pores stay inside the pores and don't leach on your hands when you touch the anodized parts, basically. And then, of course, the last part of the process, my favorite, is the wrapping of the parts. There may be, of course, some inspections, some checking of the visual consistency of the part, checking that the hanging marks are correct, that they're in the right location agreed upon, and that there is no bleeding, and that all of the holes have been properly anodized as per spec. And then when all of that is done, the parts are ready to be sent to the customer. So that's it for today. I hope you enjoyed watching this video as much as we enjoyed filming it. Of course, we're going to be doing other videos like that in the future, but let us know if you have one specific topic or one specific process you'd like to see us film. And then don't forget to like, comment, and subscribe if you'd like to stay tuned with this content.